Everyone, so today we're going to talk about the limits involving infinity. And so what I'm going to have you do here is just use your knowledge on M behavior to compute the following limits. And so when you learned M behavior in pre-calculus, you might have seen the notation as x approaches infinity, f of x approaches, and you would say, a number value or negative infinity or positive infinity. And so hopefully in the introduction to limits you made this connection that really when you were computing the M behavior of a function, you were just in fact telling me what the limit was. Okay, and so here, when I look in part A, I want to look at what's happening to my function here, e to the x. Okay, as x approaches infinity, what's happening to my function? Where is it approaching? And so here I see that as my x values get bigger, my y values, or my function, is heading towards positive infinity. And so here I would say that the limit as x approaches infinity of e to the x is just equal to infinity. Okay, and so you can note here in pre-calc we would write as x approaches infinity, f of x approaches infinity. Right, and so here that's why I'm saying, well, really you were just computing the limit. The limit as x approaches infinity of my function is just equal to infinity. Okay, how about in the next one, looking at part B here, I have the same function, but now I'm asking you what's happening to my function as x approaches negative infinity. And so here you want to look at to the left here where you have negative x values, and you want to see what's happening to your graph. Okay, what is happening as x approaches negative infinity? I see that my function is getting closer and closer to the x-axis, or in other words, my function is getting closer and closer to 0. And so I would say that the limit as x approaches negative infinity of e to the x is equal to 0. And so you want to note, again, in pre-calc, you would say as x approaches negative infinity, you would say that f of x approaches 0. And so I'll stop writing these notes about what you would say in pre-calc, but I'm really just trying to connect the idea and engrave into your brain that what you were doing in pre-calculus with M behavior, really you were already just computing limits without even realizing it. Okay, so moving on to part C, we would say that as my x values get bigger, or in other words, as my x values approach infinity, we would say that x cubed is also getting bigger, right, and is also approaching infinity. And so when I want to say what's the limit as x approaches infinity of x cubed, I would say that that's also equal to infinity. Okay, moving on to part D here, I want to know what's happening as my x values are getting bigger, or in other words, as my x values are approaching infinity, what's happening to my square root of x? Well, it's also approaching infinity, right? It's also getting bigger and bigger. And so here, I would say that the limit as x approaches infinity of square root of x is equal to infinity. Okay, what about with logarithmics here? What about with the natural log? Well, if I look at part E here, I see that, again, as my x values are getting bigger, alright, so as my x values here are getting bigger, what's happening to my graph? Well, my graph here is getting bigger as well, right? The ln x values are also getting bigger as well, and so here I would say that the limit is equal to infinity. Okay, how about the limit as x approaches infinity of log base 2 of x? Well, same idea here. It has the same exact shape as ln of x. As you can see here, as the x values are getting bigger, my function values are also getting bigger, and so I would say that that's equal to infinity.